What's up? In this video, we are going to do linear regression all in one video. Wait, that is the plan for the next video, right?
Everybody ask me how I know. I smiled at them and said she told me so. Everybody ask me how I know. I smiled at them and said she told me so. Everybody ask me how I know. I smiled at them and said she told me so.
3, 2, 1, go!
So, in this video, we are going to, make the model that we previously made a little better. How? I'll teach that. And in this one, I will be telling you a little bit of maths that I hope that you're not afraid of. Well, don't worry, it's very minimal maths, so it's pretty simple. It's as simple as addition and multiplication, so you need not worry about. We are not going into anything like matrices and complex numbers and anything like that. So just wait, have your seats and relax and just continue watching this video. Why? Well, because I hope it's interesting. Okay, and as well as in this video, I will be telling you how you can read the documentation of sklearn so that you can make better models and you can understand what all things and till what point can you push yourself. Okay, so we are here and we need to see what all is possible. Okay, so we are on computer screens and as you can see we are right here and this is a code that we previously wrote. And as we are here, okay, wait, you can just see this line that I have just made. You don't really know about this line because I have not taught you how you can make this line, but I will write it right now. So let's just do this thing. Let's just delete this and write everything from scratch again. Okay, so what you need to do? Well, this was a thing that we need to make and we need a line. Okay, so this is not definitely kind of like a linear regression thing, but the thing is that it is important and it will be really helpful when you are making some things, especially when you will be making and using TensorFlow and then using the graphs and all sorts of crazy things. Okay, so here we are, and if you remember what we did is last time we did a scatter, and inside the scatter we passed our x values as well as a y value, which in our case was data. So it was data and it was Shubham inside the data, right? So let me just run this real quick and hopefully it will run. Yeah, so this was my graph and this was the thing that I previously showed you. Now I want to tell you how can you make a line, right? Okay, but before that, before telling you how can we do that, I want you to predict how is it possible by telling you some maths as well as making you read the documentation. So I have my documentations open here. So this is a sklearn linear model and we are on linear regression. Don't worry, we will be going into something like logistic regression really soon after we complete the linear regression as well and as craftily as we can. So if you remember, when we came here and when we trained the model right here, when we were inside, there was something that it was suggesting us and there were actually 4 things. So what were those 4 things? It was fit intercept, normalize, copy x and n jobs. Okay, now fit intercept, that means you need an intercept. Now what is an intercept? Intercept, if you know about a little bit of maths which we'll be going into, so need not worry about that. Intercept is, it is a place or it is actually the distance from the origin to where your line cuts, in our case, the y-axis. Okay, so that is called as your y-intercept. So if it cuts the x-axis, so that is called as the x-intercept. If you think and if you are wondering and it's like you want to learn machine learning but you are not at all familiar with mathematics and you don't really know what I'm talking about, don't worry, we'll be going into and we'll be exactly seeing what do I really mean, okay? So don't worry. Just stay calm, don't just shoot down in the comments, okay? So it's fit intercept. Then normalize is kind of like, while doing linear regression you will see this normalize really often. Normalize is kind of like, let me just think of the best metaphor, okay? Normalize is actually, if I have a very complex thing, I want to shrink it down. So if I have my numbers expanding like 10 million or 100 million. So the thing is, you want to minimize the amount by which your computer processes. So actually there's a lot of processing going at the backend, and right now you don't have to really worry about it because, well, sklearn worries about that for you. But when we will be using TensorFlow, then you will have to do like how is it working and how can you even go and work at the CPU level, and then we'll be using not even TensorFlow, we'll be just using NumPy, and then we'll be making things. Now I know that you are really bored just listening this over and over again by me, but well, that is the plan of this course and that's what I'm going to do. So well, you're bound to listen to that, okay? And then is n jobs. Now what is n jobs? Okay, this is pretty interesting. N jobs means the number of jobs. Now what does the number of jobs means? It's not like I am here recruiting you and I'm just providing some number of jobs. Neither is linear regression helping you to find jobs, although it can, but right now it isn't. So what is n jobs? Let me just help you find it out. So here are the parameters, and you can just read it out. They have written really nicely anyways. So here we are, and inside the n jobs, it is actually how many number of jobs or how many processes do you want to run at the backend. So it's like, okay, I have a processor, and that processor is quite capable. Let's say you have an i5 processor or you have an i7 processor. I don't think that you are on i3. Even if you are, it's fine. You can really do linear regression on that, but make sure you are just in linear regression, because if you do that on neural networks, then probably you will really regret. Not because the computer will break down or anything like that, but it will be really slow. Okay, so let's say you are on i5 processor. Okay, so I'm assuming that you're at there, and then you have some sort of graphics card. If you don't have, don't worry, right now it's not required. Okay, so what happens is, if you have something like I'm just looking here, and as you can see in the n jobs, okay, what n jobs is, you have some processor, and that processor can carry out some number of tasks simultaneously. Now you want to push it as further as possible so that you can get the training as quickly as possible. So let's say you have 10 million data sets, data points to actually fit. So that will really take a lot of time, especially when you are training neural networks. Not right now, because anyways this will take some time, some amount of time. So this is actually bound to take some amount of time. So okay, now if this is taking some time, how can I minimize it? Well, by running some things more than once, or rather like running more things at once. So that will just minimize the amount of time that I have to. So that's it. So you can just set as it says, you can just set it as set it to -1. That will mean that all of the processing power that you have will be used to find it out. You can do that, or you can just say 1, 2, 3, 4, 5, 6, 7 or 1 million or anything like that. Now there is one more thing that is called as O, or the O notation. Now what is O notation? That is actually a type, or rather it's something like if I have let's say I have a list, okay, a list that has 10 elements, and I want to iterate over this list using a for loop. So the simple code that I will write is a for loop, right? So it will be for, let's say, elements in elements, and there are total 10 elements in that list. So like the list that I have is named as elements, so it has total 10 elements. Let's say hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. That's 9. Helium as well. Helium. No, helium is already included. Neon. Okay, so I have total 10 elements in it. So inside the name of the list, inside the elements, I'm going through each of the element, and then so the for loop will run n number of times, means in our case 10 times. So n is actually the number of things there are in that list. Now in case I have 100, that would mean it is it will run 100 times. So that is called as ON. That means your notation, your big O notation for a list, for a for loop, is actually ON. That means for the length of a loop, it will take more and more amount of time. So if you have 1 million elements, although we just have 118, so hypothetically if we had 1 million elements, so that's it. Okay, so in our case we are using linear regression, and there is something So you can just see big O notation for linear regression. Linear regression, it's not there. Linear regression. Okay, so let's just see. I'm just finding it out whether I can find it here. If I'm not wrong, it's log n. No, it's not log n. I guess it's log n times n. Most probably. Let's just see. Yeah, I should have gone there actually. Anyway, I would like to know what do you really use Stack Overflow for? Because you know they have many people who just copy and paste code, so I hope you are not that one. Probably I'm not able to find it out here. I will list when I'll find it. Okay, I'll even list the website where I'll find that. Okay, so that is not a concern right now. Okay, so like that is actually a thing that you need to take care of. The best one will be O1. That means no matter the amount of list that you have, it will always take the same amount of time. So that's it. Okay, so that's it. What was I trying to do? I was here and I wanted to show you how you can read these docs. So we were at n jobs, and so that you can just have the processing power. Now we have some variables. One is coefficient and one is intercept. So that is what we are interested in. Why? Why are we interested in that? Well, for that, let me just come here. But before that, I want to just quickly come here, and I hope you really remember that. And if you have not really seen this, you can go to my website, that is thecodinghumans.com. So just go there and use this for you. This is something that I built using JavaScript. Yes, I know JavaScript. I'm not in immediately. So this is something I built using JavaScript. A specific library is P5. So I used P5 as well as TensorFlow.js. So this is the linear regression thing that I made. Now let's say I have 2 points. Okay, let's say I have 2 points. One is here. So this is 1 point, and let's say the another point is somewhere here. Now, did you just see this beautiful line was animated and it just fitted this point? Let's say I have 1 more point here and 1 more point here and some more points like these. Okay, so these are some of the points that I am making for you right now. So this is, let's say, a data set, and this is how it is, and this is the line. And let's say this axis will be our x-axis and this axis will be a y-axis. Okay, now that's it, your y and your x-axis. Now what happens is, if this is my y-axis and this is my x-axis, so, and this is a line. Now let me just come to my whiteboard and draw those axes for you. So these are my 2 axes. Wait, I'm really sorry for this. I just forgot to minimize that. Okay, so it's not that I'm sponsored by any of these websites. No, I'm not. Although I hope I was. Anyways, so this is my y-axis and this is my x-axis. Okay, and the line was something like this, right? Now, what is the point that I'm trying to make? What is a line? What is a line? What is a line? Think in your mind and ask yourself. Just close your eyes and ask yourself, what is a line? If I have a line in front of me, what is a line? How can I define a line? Well, if you're a math student, you already know. For any point in y, it will be m x plus c. So y equals mx plus c. Now, if you are not really familiar with this, don't worry. It's a pretty simple equation. I'll explain what it is. So, for any point, let's say something like this. So this is a point. So the point that here is, it is this exact point on the line. Okay. Yes, I know I really made it very bad. Anyways, on this point, on this line, I have this point, and this is its y. So it's something like this. On this line, this point corresponds to some y and some x, and some x. So this is my x. So let's say it is 2 and it is 3 here. I'm just making those up. So don't really think I'm really trying to make anything here. It's not that. It's just that somehow it makes 3 on my y-axis and 2 on my x-axis. That's it. So, that said, by doing something inside this, by just doing something inside this, by doing just something inside this equation, y equals mx plus c, by putting this 2 inside x, there is a value of m and c. What is m and c? M is a slope. What is a slope? So, if you have this line, slope is actually the steepness of a line. What do you mean by steepness? Well, good question. Steepness is actually pretty interesting. Let me just clear the board for now. Okay. So, what is steepness? Steepness is actually, let me just make some lines for you. Okay. So let's say, okay, wait. I'll just make the x and the y axis. So these are our axis, the y and our x axis. Okay. Now I need some lines. I can have a line, something like that. That's a line. And I can just draw some other line. That is like this. Now I have two lines. What is the difference between the two lines? It is the angle by which it is tilted, right? That is slopeness. That's it. This line right here is less steep, or it has less slope, or in our case, as we said, it was y equals mx plus c. Let's just write it. Y equals mx. Wait a second. Mx plus c. So it is y equals mx plus c. So since I have y equals mx plus c right here, what I can do is, for this value, the value of m will be less. Okay. Now what is m? M is slope, as I said. So if the value of my m is less, that means what is actually m? If you know some trigonometry, that is actually tan theta. So it is a theta that it makes with the x-axis. So it is a tan theta. So more the tan theta, more it is. So one is that line, and let's say I have one more line like that. So this is much more steep. So it has a much greater value of m. So that is what this line is. Done? Am I clear? If I'm not, ask me in the comments, or you can just ask me on the website. I will clear it out if you have any doubts. Or when there are some awesome tutorials out there on YouTube, you just go and learn some maths if you want to. Although I can teach you as well. Your wish. I'm your person. Anyways, coming back to this, what are we up to? Well, right now we understood in this equation that was a beautiful looking equation that was y equals mx plus c. Okay, well that doesn't look like an x, does it? I don't know when will I improve here. Okay, so let me just use, so right now we just understood this one m that we had. Now what is left? Well, we have our entire c left. Now what is c? C is the intercept. I did explain you what intercept is, but don't worry, I'll explain it once again. So let me just draw my x's again, and let me just draw one more line. What is the intercept? Well, if I have this line here, the intercept is distance between this origin, means this point, and till the point where the line cuts my y-axis. So that is called as a y-intercept. Okay. So in this equation, y equals mx plus c, it is exactly that one. So how much up? So it's like starting from the origin, how up is your line? That's it. So that is what this c depicts. So it is a distance from this point to, like, it is this distance from here. I'm really bad at drawing. You might have guessed it by now. Okay, so it is exactly the distance from here till here. Yes, I erased it. It doesn't matter. Okay, so it is this distance right there. Okay, that said, Now I hope that you really understand what does this one equation y equals mx plus c really mean. Now why was I teaching this to you? Why this long story? Well, so that you can make a line and you can make the line and you can program the line. How are we going to program a line? I have my data right there. What do I need now? Well, I need an x and a y, or rather from our equation I know that y can be predicted if I have my m and c, because, well, what is x? Come back here and if you can see, it is a 0, 10, 20, 30, 40. That is an x-axis, right? So we can just use that x-axis and we are done. Okay? So, if we are here and right from here, if what I say is, if I have my x, so what do I have from this entire equation? Well, I have my x. From where am I going to get my m and c? That's what the model predicted. So I even have my m and the c. How will you access it? There are some variables to access them. How? I'll teach you. So what is my y? Well, you just put in this formula mx plus c and we'll get a y. So let's just quickly program it. So our x is our x, and for a y, I don't think I have a variable named as y, do I? Yes, I do have a variable y. So I'll just name it something else. I can say y line probably. Okay, so the variable will be y line. What is it? It was mx plus c, right? So let me just comment this out. Yeah, and one more thing that I wanted to tell you is, make sure that you do comment things out, because, well, it's really useful. So coming back, it's y. Oops. Actually, I'm on a new laptop. Not a new laptop actually. So I'm on a new system. I mean, it is a laptop, but it's not new. Doesn't matter. So actually, that's why I don't have a typing experience with this one. If you might have seen, I'm using Windows 8 right now. Previously, I had Windows 10. Okay, continuing. Y line. Well, what is Y line? We need an M. What is an M? Okay, and our M will be from our model. What we need is, well, what do we need from a model? Just imagine M was a slope. Okay, now how can I access the slope from here? Well, you can just see there are many different things, but I want you to learn from right here. It's coefficient. What is coefficient? Well, it is exactly that coefficient that we are looking for, right? It is to fit in the y. See, so this coefficient is actually our m, or the slope that we are looking for. Okay, but before that, I want to actually tell you how is this really working. Okay, so let me just tell you what my model dot coefficient is. Let me just run that and see what our model dot coefficient is. So it's an array and we have a number here. Okay, so that is our m, that is the slope. So right in here I can say coefficient, and that is the slope. What do I need to multiply it with? Well, I need to multiply it with our x. So first of all let me just enclose this in a bracket. I like using brackets, that makes things cleaner. Okay, so it is models or coefficient, so that is some number. But if you remember, it is in an array, and that's a 1D array. As I can see, most of the times probably you won't get a 1D array. You can get 2D, so you just need to check. Sometimes I do get a 2D array, but it's okay if you are getting a 1D array for now. Okay, so that's done. So I have my m. Now what is my x? Well, it's very simple. I just need to multiply it with an x. Okay, so I'm done. My m, x is done. Now what do I need? mx plus. What do I need to add it with? Well, c. Now what is a c? Well, if you come here, c was an intercept, right? It was a y-intercept, and you have an intercept right there. So it will be model dot intercept. Okay, So that's it. That's it. And your line is ready. Now how can I make it? If you have a p dot scatter, and if you throw in your x and a y line, and after that if I say that plt dot show, so if I just say that and run this, let's see what happens. Plot is not defined. Oh, I'm sorry, that's a typo. Okay, so that's a line, a very bad looking line, because that is not a line, right? That's a scatter of point, and that was the point that I wanted to make out. Instead of using a scatter, in our case we can use plot. What plot does is it plots the line and connects all the dots. So now we have a nice beautiful looking line, and instead I guess that I can just change its color so it looks a little beautiful, and I can just say color equal, and what is it color? Let's say I like red. I don't really like, but it's fine. Okay, so this is the thing that we have. Now this is a line that it predicted. It does not quite seem that it is working, and it's like, just see a graph, okay? It's kind of like this strange looking thing, and that's why I said it's not a really good thing to predict using linear regression. But it's my channel, I'm using it, and well, we did a lot of hard work. You can just see the video. I'll link it up. I just link it somewhere, so you can just see that video and see how much hard work we really did. So it was a pain in the ass. Okay, coming back. But I love you, so I will just keep making videos for you. Okay, so these are our points, and this is a line that it predicted. Lovely. But is this line actually the line of best fit? Well, for now you have to agree that it is a line of best fit, because you don't really have anything to check for that, or do we? I guess in our place inside here, maybe we can just plot this exact same graph and see how will it behave, right? But how will it plot it? Well, that is actually the thing that I need to do in JavaScript. So I will link that to the website. So when you just go there will be some buttons, hopefully. If I don't, then just remind me. I'll make those changes, and I'll make sure that this data is right there. For now, I can't really show you, but if you go to the website, that's why it's like, if you are following me with the website, so you will get all of the links and some more reading materials, some more things on the website. So you can just go to the website on thecodinghumans.com. So I hope we are humans and we are really coding. So that's why. Okay, so this is a thing. And this is a graph that it was predicting. Okay, done with it. Fine. Now what? In this video we were actually trying to optimize the things, and till now we have not really optimized it. But don't worry. The thing is, the reason why we are getting like, okay, I just run that again, and it was like minus 0.233. So it's even worse than previous one. So it's like, yeah, I guess the previous one was minus 123 or something like that. It was 123.666 something like that. I don't really remember. Okay, so right now we're getting minus something. Now why is it minus? Why minus? Okay, for that let me just come back here. Okay, and you need to find the thing that we are doing, that is score, right? Okay, so here's the score. Now what it returns? It returns the coefficient of determination r squared of the prediction. Yes, my friends, it returns r squared, and I said you, it does not just give you accuracy. It does not give you accuracy by any freaking means. Okay. So if in some video you see that it does give you accuracy, on behalf of me, just go and comment down on their video that it's not accuracy, it's r squared. At least let some people know. I don't want to pinpoint any particular YouTube channel. Yes, I don't want to, because they are really awesome. They are really great YouTube channels. Just because of one thing, I don't think we have any rights to sue them, do we? No, we don't. Okay, so that said, we are getting it negative, and actually it will be a little hard to explain it to you why it is negative, because it really requires a lot of things to explain why it is coming negative. So I will explain it to you when we will be making and we will be using TensorFlow. Yeah, when we will be using TensorFlow, not TensorFlow but JS. Well, if you want, that will be an on-demand series, okay? So if you want, I can teach this linear regression maybe in some more depth with JavaScript, and we will be making this exact thing. So this beautiful thing that we have, look how beautiful it is. No, I really love this animation. I don't know about you, but I'm a real fan of it. Okay, so how are we going to optimize it? Well, first of all, if you remember last time we did this, right? And it selected some random data and it threw it in. Okay, so that was the reason of it giving us some really bad results. Now the thing is, and one thing I would like to clear, r squared means that the thing that I explained in the previous video. If you have not seen it yet, you can just go and watch that. But it returns the r squared. Where is it? It returns the r squared of the prediction. So it's not of the model, okay? It is not the r squared of the model, it is the r squared of the prediction. One more thing to keep a note of, because r squared of the prediction won't be negative. If it is negative, then our line is wrong. Okay? It should always be positive. As far as I know. I'll research a little about that, and hopefully in the next video, when we'll be doing everything in one video, we'll be making exactly this project, but at that time in much faster pace, because well, probably this is our 5th video, isn't it? Yes, this is our 5th video, and we are just about to finish with that. And in the next video, just in one video, and I want to make sure that it's less than 15 to 20 minutes. So in that amount of time, I want to explain it to you, like how easily can we really do it. Okay, so how can we really optimize it? How can we optimize it? Well, one way to optimize it is by putting all of the data. But even if you remember that I was the one to tell you that no, never ever give the same data for training and testing. Yes, I remember. So why am I saying that we can give the entire data to the dataset and then train using that? Well, because of the fact that if we give it the entire dataset, we know that it can't fool, because we have the line that it predicts already. So it can't really fool us in case of linear regression, no matter how much data you give it. Right? Yes, that's amazing. So for this point, for fitting it, what I'll do is I will pass in my entire x and y. I guess y is y Shubham, if I'm not wrong. No, it is for Omshi. Wait, was it data entirely for Omshi? Then why on earth was I doing it for Shubham? Omshi. Oh, now I see it why it was like that. I'm really sorry guys, actually I was just out of my mind. I thought that this is my data, that I was using this on my data. Well, now you can see that the data that it is predicting is really nice, isn't it? Because this is the graph that it has, and this line really suits to be predicting that. I was an idiot. I'm sorry for that. I'm really sorry for that mistake. Okay, so Yeah, this is the graph of Ohm's tree that we are predicting. Again, I'm sorry for that. I don't know how on earth did I just did that big of a mistake. Okay, so here we are, and this is a line that is predicting, and just see, doesn't this look quite beautiful? Like this line does seem to be predicting it quite well. Okay, it really is. It really is. So where were we? We were actually about to pass in the entire dataset. Hopefully I checked, otherwise this entire series, my goodness, I would have been sued by the people in the comments. Okay. So where is my test and my train and model and fit? Okay. So it's Y for Ohm's tree. Just run this one once again and see what we get. Now for this time I'm just putting the entire dataset in, and I hope there won't be any errors. Even though there is, we can just change some bits and hopefully we'll be fine. I don't know why it's taking so long. I'm 90%. Huh. So, actually there was some error. I don't know why does it actually happen again and again. Maybe this is still in beta mode. Okay, so now it says that I need to reshape it. Well, yes, I have to. If you remember last time, we had to do that. Y equals y dot. If somebody knows a better way to do it, just let me know. I will love him. Where is it getting error? Single sample dot format. Did I do that? Plus y equals y dot reshape minus 1 to 1, and now I'm passing in y. Oh well, then why am I passing that? But I can still pass that. Because it's giving me error in my fit. So it's in x and y. But for my x, okay, so now since I'm using x, yeah, so I need to give it for my x as well. So x equals x dot reshape minus 1 to 1. Oh shit, it was minus 1, right? Yeah. Probably just a little bit better. Just a little bit. It's possible. Okay, now see. This might actually be a little better graph than before because we have added some more data. So yeah, but still we are getting it in negative. But now you can just see it was like previously we were getting in 0.023 or something like that. But now we are at 0.01. So it really reduced. Okay, so this is prediction for one. Now. Again, going back to the story. The story was that I programmed a game using Pygame, and I by mistake imported humans. So the players that were playing actually went inside the computer, and we were stuck there, and there were ghosts inside who were behind us, right? And we had to run 1500 meters, that is 1.5 kilometers. But in our case, what we have is, well, this thing, and now we can just predict some models. Now what do we want to predict? We want to predict, actually, well, now actually before continuing on with the story, I would like to show where is a tail. Actually, I think I showed you for the tail, right? If I'm not wrong, I showed you how to use the tail method. Did I show you? Let me just show it again. Okay, so tail method is data dot tail. That's it. Shit. tailor or tail. So what that will do, it will give me the last 5 results. Okay, so back in here I can just predict, let's say which one should I predict? Let's predict the 46th model. We have it right here, right? So so that's why I was actually even checking it for mine. I was actually checking for home, right? Was I? Okay, so for 46 model, it says that it is at 11 point something. Does it? Yeah. So it's at 11.9, almost 12. On 46, it's 11.36. Whoa, amazing accuracy, right? Amazing accuracy. I'm just a little too overwhelmed by this. It says 11.90 and the actual time it took was 11.36. Amazing accuracy, isn't it? Now, seeing this data, we want to predict how will he perform when he is at, well, where? Where is he? He is at, we are at 50, we need, and we did it till, well, 750 meters. We need the double. So what we need is, how much time will it take when he runs the 100th run? And it says that at the 100th run, he will take 12. Okay, so at the 100th run, he will take 12 seconds. Okay, so that is the prediction of the model. So at the 100th run, when he is running for the 100th time, he will take 12 seconds. We don't know whether that's true or not because we have not really checked it as yet. But how can we really check it? Well, we can't. But the main purpose is the main purpose to teach you this was so that you can find out who will win among Om, Aryan or Shubham. Well, I hope I win, but well, who knows, right? So how are we going to predict it? We need to see how much total amount of time everyone takes in every single run. So it's like in the first run I took this, second run, third run, fourth run, fifth run, sixth run, because we are actually counting it at 15 meter session, but for the entirety we need to run for 1500 meters. So we need to check it for a total of 1 to 100, right? And that will give me the total amount of seconds that we will take to run from the starting to the ending, right? So we need to add all of them. How? I can just show it for one. I want you to do this as a homework. Like I mentioned, I will be giving you some homeworks like I'm doing right now. I want you to, well, first of all, cut everything and write everything from the base so that you can just remember kind of some things, like you need to use model selection and all those things and linear model and how you can just do all sorts of crazy stuffs. But the thing is, like, while making all these things, you should remember at least some amount of things, right? So here we are, and what I want you to do is actually now I'm predicting the 100th model, right? What I want to predict is how much time is he going to take? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, until 100, and I want to add all of them. Okay, let's just do it right now. Let's just make that. Okay, so what do I need? I need a for loop. For, well, oh, I'm sorry, I'm actually X run in range in 100. What do I need? Out of the 100 that I have, I need each and every number, and I need to predict it, and I need to predict at those numbers. How am I predicting here? Well, this is my prediction, right? But for that, I even needed to append that to a list so that I can store how much time is it taking. So let's say Om run. So it's Om run, and let's say this is an empty list. So inside that list, I need to, okay, so I'm inside this list. What do I need to do inside this list? Well, it's pretty simple, right? Inside this list, I need something, and it's this thing. Build a plot. Sorry, it's this here. Prediction, right? So I have a prediction. In the prediction, we have this, right? We can just copy it or leave. We just write it, right? We don't really have to write much. So it's, let's say, I can say run, not rub, run prediction, run prediction. Now run prediction will be model dot predict. Inside predict, I need to pass in x run. X run. Now with that said, I have my values of the prediction in my x run. What do I need to do is, well, ohm run dot append. What do I need to append? Well, this thing right here. So this is my prediction and I need to append it right inside this. So with every time he runs, so I have what I have here is I have a list, and this is for the range till 10. So I have this for loop will be running for 100 times, and every time I am predicting how much time will it take and how much run will he make. Okay, that's it. So that what will this thing do is, it will just be a predicting, and I can just say ohm run. So yeah, so like this is ideally, it's kind of like an ideally. So I'm a geometrist, so even if you don't put a print around it, it will work. Then just put it like this. Okay, and so let me just run this real quick for you, and it will predict an array. So it's all of the predictions, right? So these are all the 100 predictions that the computer think that he will be making. So these are all of the 100 predictions that the computer just made. So he thinks that in the first it is, and slowly incrementing based on that line. Now, how am I going to calculate it? Well, for the calculation, what do I need to do is, I need to be taking this calculation and I need to be adding all of the numbers, isn't it? Now I need to say ohm total run time. Probably a very good name of a variable, ohm total run time, but a pretty long one. For now I can just say it to be 0. Now I can say for t in, now what is this actual array? What do I have in this array? So how you can just, if this is annoying, so you can just clear the output, so then you can just be here. So for in ohm run, so you can just say for this in ohm run, so this is the actual list, and inside that list, so if you remember, this is actually a 2D array, right? That's a 2D array. So what you need to do is, ohm run is actually a 2D array, so 0 and 0, and you have to say for t in ohm run, so that's the number of times ohm runs, and after that you can say ohm total, what did pop up? Ohm total run time plus equals t. So that is the amount of time that was predicted, and I'm just going to add it total. So that will be in, well, seconds. So let's say what will be the ohm total run time. I'm a very lazy guy. So let's just print that. What? Wait, I guess I have done some mistake in here. For t in this, ohm run plus equals, so it's plus t, right? Won't that be the case? Let's see what t is. 20. I'm excited. Okay, so t is actually 0. Why? Why is t 0? Maybe it's a 1D array. There should be 100 things that I'm printing, right? Ohm run. Wait. Yeah, so ohm run is actually this list. Now, Error. Put a runtime run. Ran for this long and there was this prediction. Made the list. 14 over. Let's see this. Haha. Let's see that, like, this is a 2D array, isn't it? Array. Let's see how it is totally. Yeah, so these are all 2D arrays. Okay. So it's that. Okay, I got it. Okay, so it's like this is one element. So what I need to do is take its first element, and I need to say actually total runtime plus equals t, and then I need to mention in. Okay, now I got it. Now let's see how it is. Probably a very huge number. Yeah. So this is a roll number of seconds. So let me just see how much time it is actually. These many seconds. 2 minutes. 2 minutes. Seconds, 2 minutes. Okay. Seconds. Okay, so that's 19 minutes. So he will be taking almost 19.9 for that. So that's almost 20 minutes to run this entire race of 1500 meters. Long, very long task. Okay, so this is to predict. Oh, now what I want you to do is come here, make some changes, use your mind and think what do I need to redefine and what I don't need to redefine. Make this exact thing, and I want to see who wins. Okay? And right now I just showed you for Om. Well, you need to do the same for Aryan, I need to do the same for Shubham, and I'm sure that by the time you'll do for Aryan and Shubham, that's me, so by the time you do for Aryan and me, you will have a very, very good hand at linear regression while using sklearn. You won't be knowing how it is working, but it is working somehow, and you will be knowing that it is working and you can make it work using your own hands. Okay, so that's it for now. And one more thing before I go is, after you are done with that, don't just tell me in the comment that who wins. Okay, give me the exact file name or the file link. I would definitely like to go and check each and everybody's file. I would personally go to each and everyone, even if I have, let's say, 1 million comments. That's not possible in my videos. Let's say I have 1k comments on my videos. So I will, and out of those 1k comments, let's say 500 people of you are actually giving me this thing. So I will go to each and every 500 links and I will check how have you made it. Optimize it as best as you can, because I know I've really badly programmed it, but I'm sure that you will do it much better than me. So since I know you will be doing it much better, I want to see if there is some more innovative things that you can do with it. Well, that's it for now, and hope to see your creations, and let's see who wins, because I'm just telling you, I'm not going to find it out. Although I can, but I won't be. So I want you to do that for me. I want you to go program, understand, learn, innovate and recreate this exact thing, and send the link to me so that I can see how each and every one of you is doing. So I guess that's it for now. Hope you enjoyed, and well, bye bye for now and keep innovating.